watchers. Basic example of watchers. Computed properties allow us to declaratively compute derived values. However, there are cases where we need to perform side effects in reaction to state changes. For example, mutating the DOM or changing another piece of state based on the result of an async operation. With Composition API, we can use the watch function to trigger a callback whenever a piece of reactive state changes. So we have a script and then our template. In the script, we have a ref, we import the watch, the question is a ref, the answer is a ref, and then we use a watch which takes something inside. It works directly on a ref, and the template has two paragraphs, one with an input which is connected to the question ref and showing the answer. And the watch takes as first argument the question, which is a ref, and then it has a function as a second argument. This function is an async function with two arguments, new question and old question, and it does some logic. It checks if the question has a question mark, the new question has a question mark. No question, the index of new question is larger than -1. Well, it means that it is a question, so it sets the answer to thinking. Otherwise, it doesn't do anything. And after that, it fetches some API. Then it passes the response from this API, which is, I guess, it's just a random. It gives randomly yes or no as an answer, right? If we just refresh this thing, nothing happens. Yes, no, yes, no. Apparently, it gives randomly yes or no as an answer, which is okay. This is kind of what I expect. It assigns the response of this fetch to the answer, and then it shows it here, and that's error handling. All right, seems not too hard. And if we go here and try it in the playground, we type something, and as soon as we type a question mark, we'll fetch data from this API and we'll get a yes or a no as an answer. Am I smart? Yes. All right, that went well. Watch source types. Watch's first argument can be different types of reactive sources. It can be a ref, including computed refs, a reactive object, a getter function, or an array of multiple sources. We have two refs here. We have a single ref being passed to the watch. We have a function which takes a new x value as input, and then we can have a getter where the first param of the watch is a function that kind of looks like a computed thing. Basically, it can be a ref directly, the first thing. It can be a function which returns an operation result of doing something with the refs, or not even with the refs, because these are just values. Well, yeah, but they are values from refs, so yeah, sure. And it can be an array here of multiple sources. This is a ref, this is a getter. And then the function takes an array as input with a new x and a new y and does something. Do note that you can't watch a property of a reactive object like this. Const object reactive count 0. This won't work because we are passing a number to watch. Watch object.count. This won't work. Okay, so this will not work. I thought the properties inside reactive are reactive. Okay, well, this doesn't work. Fine, fair enough. We can't pass properties inside reactive objects to watch. Instead, we need to use a getter. Because this object.count is just a number, true. This is not a reactive property. This is just a number. This is just a number. This ref x here, for example, this is not a number. We can pass it in because it's not a number. It's a reactive property. But this is just a number. The reactive thing is object. So we can't just pass this thing. Instead, we use a getter. All right. Deep watchers. When you call watch directly on a reactive object, it will implicitly create a deep watcher. The callback will be triggered on all nested mutations. So we have a reactive object, we pass it into the watch, and then this will fire every time we change any property of the object. Fires on nested property mutations. Note, new value will be equal to old value here because they both point to the same object. That's such a gotcha, man. What I'm seeing is try to avoid reactive because it has lots of gotchas. That's why I would say so far. This is kind of tricky, I would say. This should be differentiated with a getter that returns a reactive object. In the later case, the callback will only fire if the getter returns a different object. Okay. So let's make a little note here. Watch when passing a property of a reactive, and let's make it like that, reactive object to watch, use a getter. For example, watch state.count won't work. Use watch arrow state.count count and then whatever, like that. You can, however, force the second case into a deep watcher by explicitly using the deep option. New value, note, new value will be equal to old value here unless state.object has been replaced. Wait. Callback will only fire if the getter returns a different object. Yeah, that's what I would expect, right? When you call watch directly on a reactive object, it will implicitly create a deep watcher. All nested mutations will trigger this. Yeah, wait. So this, yeah, what it's telling me here is that if we pass in an object, this watch will run on all nested mutations, first of all. What it's telling me here is that this will run only when this state.SOMEObject returns something different, which is what I would expect. I would expect this. And it's telling me this watch, if we set this deep true, will run, I think it will run anytime this state changes, or if we have, yeah, I'm not sure. I'm not sure if it means this watch will run when the state properties change, or when properties nested inside some object deeply nested change. I'm not sure what it means here. Use with caution. Deep watch requires traversing all nested properties in the watched object, and can be expensive when used on large data structures. Use it only when necessary and beware of the performance implications. Watch effect. Watch is lazy. The callback won't be called until the watch source has changed. But in some cases, we may want the same callback logic to be run eagerly. For example, we may want to fetch some initial data and then refetch the data whenever relevant state changes. We may find ourselves doing this. We have a URL ref, we have a data ref, we have an async function fetch data, and we have fetch data, which runs immediately. And then we watch for the URL to change and then run fetch data. This can be simplified with watch effect. Watch effect allows us to perform a side effect immediately while automatically tracking the effect's reactive dependencies. The above example can be rewritten as watch effect, and we have the async, we have this thing basically. Alright, here the callback will run immediately. During its execution, it will also automatically track URL value as a dependency, similar to computed properties. Whenever URL value changes, the callback will be run again. You can check out this example with watch effect and reactive data fetching in action. We have a script, we have a template, we have some styles. The script has a watch effect, and then there is a function truncate, a format date, and this just runs first, and then every time the URL changes, which I guess I can do with this, there is a input type radio for branching branches, and then the branches have a current branch, ref branches, then the data shown here is HTML URL commits. Yeah, the commit is updated when the current branch changes. Exactly what it says here. So if I change here, the current branch changes and the data is fetched immediately and it reruns. But of course, because we had already some values first, this thing ran also the first time. If we refresh the page, this already run. That's what it's trying to tell us with this example. So watch will only run when the value triggers, but also will not run initially first time. That's why we would need to have a fetch data function, run it initially, and then run it also every time the URL changes. With watch effect, first of all, we just throw in a function inside, which is basically this fetch data function. This thing is going to run initially, and then it will run every time its internal dependencies will change. In this case, the URL value. Tip: watch effect only tracks dependencies during its synchronous execution. When using it with an async callback, only properties accessed before the first await tick will be tracked. Okay, watch versus watch effect. Watch and watch effect both allow us to reactively perform side effects. Their main difference is the way they track their reactive dependencies. Watch only tracks the explicitly watched source. It won't track anything accessed inside the callback. In addition, the callback only triggers when the source has actually changed. Watch separates dependency tracking from the side effect, giving us more precise control over when the callback should fire. Watch effect, on the other hand, combines dependency tracking and side effect into one phase. It automatically tracks every reactive property accessed during its synchronous execution. It is more convenient and typically results in terser code, but makes its reactive dependencies less explicit. Should be pretty clear, right? Callback flush timing. When you mutate reactive state, it may trigger both view component updates and watcher callbacks created by you. By default, user-created watcher callbacks are called before view component updates. This means if you attempt to access the DOM inside a watcher callback, the DOM will be in the state before view has applied any updates. If you want to access the DOM in a watcher callback after view has updated it, you need to specify the flush post option. Alright, so that's the third option, an options object, and one of the possible options is flush post. Alright, post flush watch effect also has the convenience alias watch post effect. So we can import watch post effect and then we throw it in here. Executed after view updates. Alright, stopping a watcher. Watchers declared synchronously inside setup or script setup are bound to the owner component instance and will be automatically stopped when the owner component is unmounted. In most cases, you don't need to worry about stopping the watcher yourself. The key here is that the watcher must be created synchronously. If the watcher is created in an async callback, it won't be bound to the owner component and must be stopped manually to avoid memory leaks. Here is an example. Script setup, import watch effect, and then we just run this watch effect here. This is going to be automatically stopped when we unmount the component. But if we asynchronously add a watch effect, for example with a set timeout, then it won't be automatically destroyed or unmounted. To manually stop a watcher, use the returned handle function. This works for both watch and watch effect. Okay, right. So the watch effect returns a function, and if we call this function, then we manually stop the watcher for both watch and watch effect. Note that there should be very few cases where you need to create watchers asynchronously, and synchronous creation should be preferred whenever possible. If you need to wait for some async data, you can make your watch logic conditional instead. So we have a data to be loaded asynchronously, then we have, its data is a ref. Then we have this watch effect. If data has value, then do something. All right. So next is going to be template refs, but first we'll take a little break.